In the last time, I talked a little bit about the lighting or the quality of the visual environment. A few more points are there just to give few more updates. Uh, I'll I'll tell few more things related with this. So here you can see this is very interesting diagram actually. The first one is a very dark zone. This one, general illumination in low traffic zones or where visual requirements are simple. So that is this zone. Okay. The second one is the B zone, that is this zone, and third zone is this where additional illumination requirements. So what it indicates, basically the kind of lighting requirements in the lux for the different jobs. So this is like the broad grouping in three different kind of the activities. So here if you see, yesterday I was talking about like very high intensity light is needed like for surgery, very special visual tasks like surgery, or microelectronic assembly, microelectronic and watchmaking. So there are various kind of the tasks where the different level of the lighting is needed. So it is very low where the visual requirements are very simple. So just like the zones open in public spaces with a dark surrounding like this. So this is one thing. Okay. So this is the second thing where we will see the kind of the color of the object, and accordingly the choice of the suitable background from the visibility point of view. So like the color of the object black, and then corresponding background color is yellow, then green, white, red, white, blue, white. The object color is white, then it is blue. Okay. Black, white, yellow, black. So the object colors and the corresponding background colors, which gives you the good contrast, those are used suitably. Okay. This is another very important the diagram which shows of course the visibility depends on the size of the object, and the distance and the angle of the vision. Okay. So depending upon this is the kind of the diagram we saw in case of the principles of motion economy. What we have seen that there is a normal working area or maximum working area depending upon the distance from the arm, distance that can be covered using arm with fully stretching or without fully stretching. Okay. So here there are like the most common area was somewhere here from both the sides. But this is the different thing. Here what we are talking is what we are talking here is this, like considering the work movement, that's the body movement, hand movement. Okay. And the kind of the visual efforts that are needed. So those the jobs which are the jobs which need very high movement of the jobs, or the controls or devices that need significant movement of the hands, and as well as the visual efforts, means very frequently careful observation is needed for successful operation. The area selected is the zone 1 is this. So this is the most preferred location for putting in the controls and putting in the things which will be mostly used during the work. So this is the zone 1, and the range 2, that is this the less frequent movement and the frequent visual. So this is little wider. Okay. That is this one. So if you see this, this comes out to be about 15 degree below the 10 to 15 degree below the normal as far as the visual aspect is concerned. and the distance which is around, like say this distance is around say up to 50 centimeter or so. So the zone 1 and the zone 2 is the second, where less frequent movement and frequent visual requirements are there for successful operation. The zone 2 is the second one. Then thereafter we have zone 3, both the sides. Okay, zone 3 is where it implies that little time is needed for doing the job, and the visual information is not important. So something that you are doing casually and it doesn't take time to. Fourth zone, zone 4, is this one where even less frequency of the job is needed and further lesser time within no visual effort in particular. So we choose the zone 4. And the zone 5 should be avoided in all the cases. This will be causing more fatigue, both to the hands as well as to the visual problems. Okay, this is about the location, like how the thing should be located, light source should be located. So greater is the height, better it is to reduce the glaring effect. So if this will be causing the more glare as compared to this, so this angle is about 45 degree. A higher is the better to reduce the glare. Similarly, depending upon the size of the room, if the room is small or if the room is big, so the light sources which are at lower angles will be causing the greater glare as compared to those which are located at a higher angle. So here this at higher angle will be causing the less glare as compared to this case. So locating the light source suitably, about this I have already talked, like the visual capabilities or visibility of the human being comes down with the age, and you can see here with the age it can reduce up to the 50%. This is another design aspect, like this is the light which is preferred. The light which is more diffused will be causing the less glaring effect. So this is the general illumination, and this is the case of the local and the general illumination both. This is the most general illumination, and this is localized as well as the general, and this is the generalized localized illumination. So depending upon the kind of, this will be causing the minimum glaring effect. Then so I'll come back to this again. What I want to show here is that this is the most preferred and the useful area which will be used for locating most of the controls, which will be used very frequently, and locating in this zone will be causing locating the display devices in this zone will be causing the minimum visual efforts. Okay, so this is the most preferred location for locating the control and display devices. But since the control and display devices can be so many, so which one is to be located where and how to take a decision of which method of coding the control devices is to be used, where they should be located. So about that I will talk now using this. So here if you see what we have talked in the last lecture, like there are various coding methods. Okay, so the coding of the controls you can do using size, shape, texture, location, and the color, and labeling. Okay, these are the different methods of coding the controls. So which method is to be used for coding purpose, that will depend upon the number of controls that need to be used for the coding purpose. The space or area available for locating these controls. There may be space limitations also, so you cannot use all the coding methods everywhere. The kind of the illumination or the visual quality available or the lighting available, the kind of the force or the load that is needed for operation while using the control, and then criticality or the importance of operation, criticality or importance of control, particular control. So something which is most important and there is a question of life or death. Then of course something which is extremely important for success of the operation will be located in the most preferred location. So as far as these three factors are there, like shape and the texture, these are the two coding methods. Okay, this the shape and texture and the location, these are good location also, even size also, all these are very good for the low light or low illumination condition. But there are many problems related with as far as the shape is concerned. Shape cannot be used for so limited shape coding method is limited to the few number of controls. Okay, then there is a possibility of a problem in detection when the gloves are used. So when there is a use of gloves, then the shape or the texture cannot be differentiated much. Okay, and there can be the sensitivity issues. One may not be able to detect the kind of shape or texture easily. Okay, similarly, as far as the location is concerned, the location related coding is good for low lighting, but this offers the limitation of the very few number of controls can be coded using this, and this needs the more space whenever this coding method is used. And you'll see there is no specific identification. You see, you need to just tell inadvertent, there will be possibility of inadvertent error also. So no fixed identification using this method. Now coming to the size related method, this is also good for the low lighting, but it suffers with the problem same as the location related factor, and there is a possibility of the inadvertent error when the size coding is used. One is control is of the smaller size, another is of the bigger size, so one may use incorrect control inadvertently. Now there is another category of the controlling methods like the color and the labeling. In these two cases in both these cases you need good lighting. Without lighting you cannot use these, and the area must be in direct line of sight. So these are the two things. It's very good, there is no possibility of the error or mistake, and you see the color coding can also be used for moderate number of controls, and but there should be good lighting, and the area of where these to be located must be in good line of sight. Okay, and this of course these cannot be used, both these methods cannot be used when there is low lighting or there is a possibility of having the darkness. Now coming to the another aspect, that is about the control and the display devices. Okay, so control and display devices, what these are. So I have already talked about that there are different types of the control devices, and what are the display devices I will talk little later. But related with these both these two. These are the two coupled ones. Like here you have one lever and here you have a display. Okay, so the lever is moved left side, right side to achieve the desired setting, and the setting position is shown in the display. Okay, so what is the extent of the movement that is being given to the control and the corresponding movement being shown on the display. So basically the control is being used to change the different settings which is represented or shown by the display. So there is a kind of technical parameter which is called C by D, control divided by the display ratio. What this ratio is? The ratio of the movement of the control divided by the extent of movement of the display needle which is taking place, or display units which are taking place. Like there is a possibility like you move the control by 1 to 10 and the display device is moved like say from 1 to 500. This is one situation. Or the display control device is moved just by 1 to 3 and the display 1 to 30 and the display device is moved just by say 1 to 50. So what is the difference? C by D ratio here is very low and C by D ratio is very high. You are moving more control and display movement is less. On the other hand, here you are moving the disk control with the very less amount from 1 to 20, 1 to 10 or 20, and the display is moving by the unit of 500. So when the C by D ratio is very low, means little movement of control will be giving you the greater change in the reading of the display. On the other hand, high value of the C by D ratio means lot of control movement will be needed to bring in the small change in the display setting, and that is why the low C by D ratio is used for coarse fast setting. Okay, like you want to set the value from 1 to 212. Okay, or you want to set the value from 1 to 10.52. Okay, so what is the difference in these two? Here you need accuracy of setting up to 0.52 and here it is just 1 to 200. So 1 to 10.52. So when a very fine setting of this kind is needed, it will be fine to use the high C by D ratio, because more control movement will allow with the less display setting movement will allow the finer setting. So for high C by D ratio is used for fine setting, just like in microscopes, little movement, lot of movement of the screw or the knob will be leading to the small movement of the table. And here when the low C by D ratio is used, this will be good for the coarse setting or fine setting. So just a small movement will give you the very large change in the display setting. So if you see the relationship between the C and D, C by D ratio, so when the C by D ratio is very small, okay, C by D ratio means very small movement of control will be giving the large movement of the display. So in this case the travel time is very less. Travel time will keep on increasing as the C by D ratio will keep on increasing. On the other hand, fine setting time, so here we have the time. So fine setting time, it is when C by D ratio is very low, it takes very long time to reach there and then come out with the correct setting fine value of say 10.52, or here like say change from 1 point, so here 1.1 to say 500. So this will be it will be taking so here it will be taking less time. So this is, you can say, the travel setting or the coarse setting, and this is about the fine setting. So when C by D value is less, it takes long setting time. So fine setting or fine setting time is more, and the coarse setting time is less. So if we combine both these, then somewhere here the total setting time, the total time will be shown like this. The major change in the reading and then fine setting or fine adjustment in the reading. So if both are clubbed somewhere for intermediate value of Cyd, we find that total setting time is minimum. Otherwise it will be high, initially high for the low Cyd value, and again it will be high for high Cyd value because of so here you see the travel time or major setting change time is less, but the fine setting time is more when Cyd ratio is less, and when the Cyd ratio is more, travel time is more and fine setting time is less. So the total time is minimum for some intermediate value. So that's why it is important to choose the Cyd value very judiciously. Okay. Now we have to see the location of control, where these controls need to be located. So controls are located based on the importance, the quick identification, how easily you can identify the ease of operation, how easily you can operate these controls, and the possibility of reduction in error in emergency. Okay, so the reduction in error in emergency, ease of operation, quickness of identification, and the importance. These are the factors that are considered while selecting the suitable location for locating the control. And what we consider when locating a particular kind of the control device, we consider the kind of the sensory device based on which the control will be identified. So the human sensory requirements which are needed for identification, then anthropometric aspects. So anthropometric aspects are related with the use, like whether the leg will be used or the hand will be used, what will be the reach of the hand, like that. Then mechanical aspects of the body, like the position which a body can take, and the how much force can be applied by the body in that position. So position and the force related thing are about like biomechanical aspects of the human body, anthropometric aspects, and the human sensory aspect, and lastly the importance of operation. So considering these, the suitable location for locating the control and the display devices is identified. Okay, so as far as the importance is concerned, which one will be used, means there can be number of controls which are to be located. So how to prioritize the location for particular kind of control. So prioritization of locating the controls. All controls may not be equally important. So based on the importance, something which is most important will be located in the most preferred area. Okay, so what is the most preferred area? I have already said that with respect to the 15 degree from the below the normal, like this. So area, this is the like 10 to 15 degree below the normal, and the dimension wise this can cover like 10 to 55 centimeter. This is the most preferred the area for from the visual aspect point of view. And then if these are the hands which are to be used, then the ease of reach and ease of reach of hands or feet. So how easily these can be applied, or whether the toe will be used or heel will be used. Based on this, we use this from the visual point of view this, and from the hand and leg point of view, these are the aspects which are considered And when we have identified like this is the most preferred location for locating the control, we need to see the importance. Something which is most important will be located in the most preferred area. Second is the frequency of use. Frequency of use. So something which is very frequently used or less rarely used. Accordingly, the controls will be located. Then there is a functional type. Something which the controls which are of the similar type will be located at the same place. There are controls for increasing the speed or decreasing the speed. So based on the functionality, like on or off controls will be located almost close to each other. Then sometimes the controls are also located in light of the sequence of operations. Okay, sequence of operation, like we gave the example of the ABCD. Okay, ABC in case of the automotives, or the clutch and the brake. Okay, so these are this is about the location and the way by which it is done. Now I'll show you a little bit about the about this I have already said. So if you see this, there are different kind of the controls and display devices. Okay, so here what you see here, this is the dashboard of the aircraft. Okay, this is the dashboard of aircraft. So you will see so many display things now, and these are the controls. So you move these things and you will see the changes here. So it will be showing the so many parameters. This is another kind of the display devices. Okay, so these are the different types of the display devices. In all these cases, what you will see that scale is fixed and pointer is moving. Scale is fixed, pointer is moving. So you have very wide range and you get the accuracy also of the data. You see, this is the one which is most versatile, like because it covers wide range and it shows the data accurately. This is one. If you talk of like so when the rate of change of data is not that high, then these kind of the things are very effectively used. But you see, another thing is the digital display. Digital display devices are not good, especially when you have the very fluctuating the values are fluctuating so fast that you are not able to, like, say, get any idea of. Okay, so there are the different types of the display devices and they are labeled and the coded in different ways. So this is the Cyd ratio I was talking. Like you have lever, you move small or more, you move it by little magnitude or give more movement, and accordingly you will get the display movement. Okay, and this is called the Cyd ratio. So Cyd ratio I have already explained, like it comes out to be a relationship like this regarding the total time. Okay, and here you have Cyd and here you have time. Okay, so that's all about these about this one. I still have 2 minutes, so let me talk a little bit about these okay, so there are three types of the display devices. One is the fixed scale, the second is the fixed pointer where scale is moved, and here the pointer moves. In this case pointer moves, and in the second case fixed pointer, scale moves, and third is the digital display. So I have already said, like, digital display is not good. When the value is static, it's good, but when the value is very dynamic, it's not good. Now these display devices can be of the different kind, like qualitative. You write values 1, 2, 3. This is 1. You get the value 1, 2, 3, so it has no meaning. Then you write ABC. You write the display is shown like this, which also has no meaning. So there are few qualitative. Another is quantitative display. in quantitative display you write you get the temperature, you get the minutes, you get the pressure, you get the kg per centimeter square, like this. So values are in terms of the numerical values. The display will be showing the things in numerical values. Then the working condition, like you get the green or you get the red or you get the yellow. So depending upon the status, you must have seen when in the operation theater, when the light is red, means the operation is on, operation is over, or it is done, it is green, like that. So there are different ways of developing the displays. Then there is a alphanumeric kind of the display, which also includes like signboards and then placard. Then there is a color coding. Color coding for the display you have, like for acetylene it is red, for the blue or black for oxygen. Similarly, when there is a red, yellow and the green signals for the different kind of the situations, the different kind of the color codings are used. So that's it from my side as far as the control devices and display is concerned. Now we'll switch over and move to the test. Okay. So I'll share the link here to you from this Times this chat window. You can use that.